The circle is one of the most fundamental shapes in mathematics and in our world. Today, we're going to explore its key properties and discover the formula for its circumference. Here we have a perfect circle with a radius of 2 units. You might notice that every point on this circle appears to be the same distance from the middle, which is exactly what defines a circle. This yellow dot represents the center of our circle. What makes a circle special is that every single point along its edge is exactly the same distance from this center point. This equal distance property is what gives circles their perfect roundness. This red line shows the radius of our circle. The radius, labeled as r, is the distance from the center to any point on the edge. For our circle, the radius is 2 units. No matter which direction we measure from the center, this distance will always be the same. When we extend the radius to go all the way across the circle through the center, we get the diameter, shown here in blue. The diameter connects 2 points on the circle and always passes through the center. Since it's made up of 2 radii extending in opposite directions, the diameter d is always equal to 2 times r, or 2 times the radius. Now let's focus on the circumference, which is highlighted in green. The circumference, labeled as c, is the total distance around the circle. If you were to take a string and wrap it exactly once around this circle, the length of that string would be the circumference. The question is, how does this circumference relate to the radius we saw earlier? Throughout history, mathematicians noticed something remarkable when comparing the circumference of a circle to its diameter. For any circle, no matter its size, when you divide the circumference by the diameter, you always get the same number. This special number is approximately 3.14159, and we call it pi. This discovery gives us the formula for the circumference of any circle, c equals 2 pi r. Since the diameter equals 2r, we can also write this as c equals pi times d. This means that for our circle with radius 2, the circumference would be 2 pi times 2, which equals 4 pi units, or approximately 12.57 units. The beauty of this formula is its simplicity and universality. No matter how large or small a circle is, its circumference will always be exactly 2 pi times its radius. This relationship between the radius and circumference is one of the fundamental properties that makes circles so important in mathematics and in our world. Let's explore how a circle's circumference can be understood through regular polygons. We'll start by looking at a circle with a radius of 2 units.